All right, next up is the nomenclature of acids. Acids are a special type of molecule. They both have covalent and ionic properties. So for now, what we're going to do is we're just going to kind of treat them as a separate thing. We have an acid chapter this semester. We have an acid chapter next semester. They're really important. So right now, we just kind of need to get a general idea of what acids are, and then we'll fill in the gaps later in those other sections that I just mentioned, okay? Acids for us are this semester are going to be things that produce H plus when dissolved. Again, we see that H is acting as a cation here, okay? So when we say when dissolved, we're talking about going into an aqueous situation when we dissolve them in water. So the general form of an acid is something that starts with H and is aqueous, okay? So that's how we're going to identify that we have an acid. It starts with H and it's aqueous, okay? There are two main types of acids. There's going to be a binary acid, right? And the way that you're going to identify that is you will not see a polyatomic, all right? So when you have a binary acid, this is the general way that we name it. And this part here is what gets replaced. Whenever we have a binary acid, it's always hydro root ic acid. And this root comes from the anion. Whatever that H is attached to, you use its root and you put it there, right? And the easiest thing to remember is something like HCl. You're probably familiar with already, right? HCl, when it's dissolved in water, is an acid. Do you see any polyatomics here? No. We do our identification step. There's an H and an aqueous. Oh, it's an acid. It must be a binary acid because there's only two things present with no polyatomics, all right? This is going to be hydrochloric acid. Right, hydrochloric acid. Let's do another couple examples. Let's do H2S. Aqueous, all right? Again, we realize it is an acid because we see the state given and it starts with an H, right? State given and it starts with an H. We always start with hydro, all right? This is sulfur, so it's going to be hydrosulfuric acid. Right, hydrosulfuric acid. One more. What about going the other direction? What about hydrofluoric acid? All right, starts with hydro. I just need to have one thing attached to the H, and it's not going to be a polyatomic ion because I see this. This is HF, aqueous. Now, how do I know that? I look for this root and then I translate it to something from the periodic table, right? So binary acids, pretty common, but pretty straightforward to name. The other type of acid that we have is known as an oxoacid. Now, with oxoacids, all right, you see a polyatomic ion. And that polyatomic ion will have oxygen in it. So that anion that we had listed, all right, that is a polyatomic ion now. So that's how we differentiate between a binary acid and an oxoacid. Okay? So for example, oh yeah, and then the rules for that are we don't start with hydro. So the way that we name these, all right, is we use the polyatomic root, but then we change the ending. And I'm just going to leave this blank here and I'll explain what it means. All right, and then we end with the word acid, right? So we use a polyatomic root, and this ending depends on how the polyatomic ends. So if the polyatomic ends in ITE, then for the acid, we turn that into OUS. Ite becomes us, all right? If it ends in ATE, all right, the polyatomic root is used, and then the ATE is replaced with ic. Ite becomes us, and ate becomes ic. Okay, so the easiest thing to do, again, as always, is to look at some examples. So here's an acid. It starts with an H. It's aqueous, but notice it's not just attached to one thing. It's attached now to a polyatomic ion. We see a polyatomic ion as the anion attached to the H pluses. This polyatomic ion is sulfate, right? Sulfate. So what happens is when we go to name this acid, we're going to use the sulf, right, root, right? I'm actually going to go all the way to UR, so we're going to go sulfur. And then what happens to ATE? ATEs become IC. So this is sulfuric acid. So now you can see the rules kind of playing out in real time here, right? Let's do another example. What happens if we make this, right, H2SO3 aqueous? Again, it fits into our acid realm of things. It fits into our identification of an acid. Starts with H, is aqueous. It's also an oxoacid because I see a polyatomic ion. This polyatomic ion is SO3 minus 2, and it's sulfite. So what happens to this ITE? It becomes OUS. We never use hydro for an oxoacid, so this becomes sulfurous acid. Okay, and that's kind of it. Two different types of acids. If they have a polyatomic ion, ates become ic, ites become us. If they do not have a polyatomic ion present, or you don't see a polyatomic ion present, but you do recognize it as an acid, then it's always hydro root ic acid. And that's pretty much it. We need to know how to name these. Again, later on in the semester, we'll kind of deal with a whole chapter, or a part of a chapter, I should say, dealing with acid behavior and what we can do with acids. But again, kind of establishing ideas associated with acid, that the H is acting like a metal, is something that's going to be crucial to our understanding later on when we revisit these types of molecules.